We've been covering solving systems of linear equations. And when we solve systems of linear equations, we get to the point where two lines intersect. Now, what if there isn't just one point where they intersect? There are some cases where they don't intersect, and there are some cases where they intersect more than once. But those are special cases, and those are the cases we're looking at today. For example 1, we look at 3x plus 2y equals 10, and 3x plus 2y equals 2. We had several ways we can look at solving these equations, but since they're so similar, I want to use elimination. Notice that when we subtract these systems, 3x minus 3x is 0, 2y minus 2y is 0, 10 minus 2 is 8, and so we get 0 equals 8. Is that even possible? Of course not. So this system of equations has no solution. Well, what two types of lines would have, or what type of a pair of lines would have no intersection? Parallel lines. So these two lines would be parallel. The system has a special name though, it's called inconsistent. A consistent system has a solution. So an inconsistent system has no solution because it's parallel lines. So this is an inconsistent system, and it gives us no solution for these two lines. Now on the other hand, we might have a set of equations that has multiple solutions. Let's look at this set of equations. This one is perfectly set up for substitution because our second equation is solved for y. So let's plug that into our first equation. X minus 2 times 1/2 x plus 2 equals negative 4. So when you use the distributive property, you get x minus 4 equals negative 4, and x minus x is just 0, so we get negative 4 equals negative 4. Well, that's a statement that's always true, and it doesn't matter what the x value is. So we could use any possible x value. And then with that x, with any x value, we get a y value to go with it. And so we have an infinite number of solutions. Well, what two types of lines would have an infinite, or what pair of lines would have an infinite number of intersections? They'd have to be the same line. The only way that two lines could intersect more than once is if they're the same line. Because if I've got a straight line, and I've got another line that crosses it here, and here, and here, and here, the only way that a straight line could cross that line there, and there, and there, and there, is if it were the same line. So we have infinite solutions, and this type of system is called a consistent, because it has a solution, so it's consistent, but dependent, because the two lines depend on each other. So that is a consistent dependent system with infinitely many solutions because they're the same line. Now, the way we can tell what type of lines we have if we're in slope-intercept form, we have one solution if they have different slopes. Because if they have different slopes, they can't be parallel, and they can't be the same line. So that must mean they intersect at one point. They have no solution if they have the same slopes. That makes them parallel, but they have a different y-intercept, which makes them different lines. And we have infinite solutions if we have the same slope and the same y-intercept, making them the same line. So if we look at example 3, it gives us two systems of equations. And we want to determine if they are inconsistent or consistent dependent without going through every step. Let's look at the one on the left. If we were to rewrite each of these in slope-intercept form, that's one way we can approach it. The top one we would do just by subtracting 5x from both sides. That's negative 5x minus 2. The bottom one, we'd add 10x to both sides, which give us negative 2y equals positive 10x plus 4. And then dividing by negative 2 would give us y equals negative 5x minus 2. Notice that that matches our top equation. So those are the same line, making these a consistent dependent system with infinite solutions. On the right, this one's identifiable by the fact that the left-hand side is identical, but the right-hand side is different. So if I were to solve these and write them in slope-intercept form, I would get the same slope but different y-intercept. So whenever my left-hand side is identical and my right-hand side is different, I automatically know that this is an inconsistent system. Now that's not the only case, but this is one of the most obvious cases. It's an inconsistent system with no solution. When in doubt, just solve it out and compare them in slope-intercept form, or use elimination and substitution. Now, sometimes this causes a situation where we can't find an answer. If we look at example 4, an artist wants to sell her prints of her paintings. She orders a set of prints for each of her 2 paintings. Each set contains regular prints and glossy prints as shown in the table. Find the cost of one glossy print. So we got regular, glossy, and total price. So if we sell 45 regular, 30 glossy, costs $465. If we sell 15 regular, 10 glossy, costs $155. So if we want to set up equations, we take 45 regular prints and we want to multiply by the cost of a regular print. That will give us the total amount spent on the regular prints. And we take 30 glossy prints and multiply by the cost of the glossy prints. So x will represent the cost of the regular prints, y will represent the cost of the glossy prints. And together for that package, it's going to be $465. For the second package, we're doing 15 regular prints at x dollars a piece, and $10 for the glossy prints at y dollars a piece. It's going to total $155. And so we would want to use substitution or elimination to solve these. Well, one thing we do when we use elimination is we want to match up the variables, or the coefficients of the variables. So we'd have to multiply our second equation by something. Notice that if we multiply it by 3, we get 45x plus 30y, and 3 times 155 is 465. So that's identical to our first equation. So that means that the two lines are exactly the same. So we have infinitely many solutions. That means we can't determine any one set of prices that gives us this setup. So this is not a solvable problem. Alright, I'm going to give you 2 sets of equations and I want you to determine which has infinitely many solutions and which has no solution. So the first set is negative 3x plus 5y equals 6. Second set has 6x minus 10y equals negative 12. Sorry, that's the equations for the first set. The second set is 9x minus 5y equals 12, and 9x minus 5y equals 8. So take a minute and see if you can figure out which has infinitely many solutions and which has no solutions. Okay, so if we look at the one on the left, notice that if we were to use elimination to solve and we multiplied the first equation by 2, we'd get negative 6x plus 10y equals 12. Now that's not completely identical to the second equation, but notice that when we add the two equations together, 6x and negative 6x is 0, negative 10y and 10y is 0, and negative 12 and 12 is 0. So that's infinitely many solutions because we got a true statement, 0 equals 0. The second one, we have an identical left-hand side, different right-hand side. So that's one of our no solution cases. All right, if you have any questions, feel free to ask. If not, you can move on to your homework.